Right, this is the second part of the memo on the worksheet with extra examples on optimization, rates of change, and calculus of motion. So this particular one is question 11 in the Department of Basic Education, National Senior Certificate, February-March 2013. And that is going to appear in your worksheet on page 2, right at the bottom. So in your worksheet, page 2, right at the bottom. Now, in this particular question, it says, a rectangular box is constructed in such a way that the length of the base, so we've got the length of the base over there, is 3 times as long as the width. So the width is given as x. So we can immediately go and we can say the length is equal to 3 times the base, which is 3 times x. So you can put that information down there. The material used to construct the top and the bottom of the box, so very careful, the material used to construct the bottom and the top, so this one and this one right there, costs 100 Rand per square meter. So this is 100 Rand per square meter. And this is also 100 Rand per square meter. The material used to construct the sides of the box, so the sides obviously would be those 1, 2, 3, 4 sides over there, so that's all the sides, and that is costing 50 Rand per square meter. Right. Then it says the box must have a volume of 9 meters cubed. So let's write that down as well. The volume of the box must be 9 meters cubed. So let the width of the box be x meters. And like they said the box is x meters. So the length, which we've already established, it's 3 times the width. So that's going to be 3 times x. And then we have the height of that box as well. Now the very first question they ask over here is they say in 11.1, determine an expression for the height of the box in terms of x. Now, if I want to determine the height of the box, I have to first go and look at information that's been given. And the easiest piece of information that's been given here is the fact that they told me the volume of the box has got to be equal to 9 meters cubed. So we first look at that piece of information saying, how do we calculate the volume of a rectangular box? And you should know this off by heart. They're never going to give you the formula for calculating the volume of a rectangular box. You guys should know it's length times breadth times height. So the length times the breadth times the height is supposed to be equal to that 9 meters cubed. So we can start off by saying, okay, but I know the length of this box has got to be 3 times the width, which is x. So my length is 3x. My width or my breadth is equal to x. Then we don't know what the height is at this stage, but we do know if I multiply those 3 together, it's going to be equal to 9. And this is how we're going to get the height of the box in terms of x. We can then immediately go and we can say, height is then going to be equal to 9 divided by the product of those two. And I quickly just multiply that first. I'll go, it's 3x squared times the height is 9, which then means the height is equal to 9 divided by 3x squared. And please, please, people, don't leave it like that, because you can simplify it. It's got a common factor of 3, so we can say the height is then equal to 3 over x squared. So if you can simplify a fraction, you have to simplify a fraction. Please don't be lazy with stuff like that. Okay, right, let's look at the next question. And the next question, question 11.2, then asked, show that the cost to construct the box can be expressed as C, and I'll write this down at the moment. Please remember, be very careful. The word show or prove in mathematics means you can't actually start with what you're trying to prove or start with what you are trying to show. You've got to be very, very careful with that. You have to go and you first have to start with the other information and then the end, and that's almost why you want to go and not write down that formula, that cost formula at the beginning. You almost want to write it down at the end. So never start with what you're trying to prove, always end with what you're trying to prove or show. Okay, so let's first just go and say, they now want to ask us, what is the cost to construct the box? So if you think about it, then you should hopefully realize that the surface area times the price per square meter is then actually going to give you the cost of that box. So because we have two different prices, the one price is for the top and the bottom of the box, and the other price are for the 4 sides of the box, we then have to go first and we have to construct what the area is going to be. So we can first go and we can look at the area of the sides. And the area of the sides, if you think about it, there's going to be two congruent rectangles, front and back, and there's going to be two congruent rectangles which are going to be to the left and to the right. So the first rectangle up top there is going to be the length times the width or the breadth, and there's going to be two of them. Oh, sorry, that's very wrong. I apologize profusely about that, because I'm busy with the sides. I'm not busy with the top and the bottom. I'm busy with the area of the sides. Okay, so the area of the sides, this one specifically is then going to be length times height. That's the front and back, and there's going to be two of them. So it's 2 times length times height, plus then the other sides is going to be the left and the right over there, which is then going to be equal to specifically the breadth times the height, and there's going to be two of them. And therefore it's going to be 2. We've already said the length is equal to 3x. We've already established that the height is equal to 3 over x squared. Plus there, the breadth or the width we've said is equal to x, and we've said the height is 3 over x squared over there. So that one, if you simplify, it's then going to be equal to, I'll just put this over 1 so you guys can see it a little bit better over there. So this is going to be 2 times 3 times 3. So 2 times 3 times 3 is equal to 18. And then this x will divide into that x there at the bottom, so that means it's going to be 18 over x. Plus then, and I'll put these over 1 as well so you can hopefully see, 2 times 3, which is going to be equal to 6. And again, x will divide into x squared, x times. And because these are like terms, I can say 18 over x plus 6 over x is going to be equal to 24 over x. So that's the area of the sides. Then we can go and we can look at the area of the top and the bottom. And that's quite easy, because that's just going to be equal to length times breadth, and that's also going to be 2 because there are two of them. And we know the length is 3x, and we know that the width is going to be equal to x. So that's going to be just 6x squared. Now, we are not done, because obviously what they wanted us to calculate is they wanted us to calculate the cost. So the cost specifically is going to be equal to 50 times the area of the sides, because they told me that the sides cost 50 Rand per square meter, so that's 50 times that 24 over x, plus then 100, because they said it costs 100 Rand per square meter for the top and the bottom, so that's going to be equal to 100 times 6x squared. So if I simplify that, and I say 50 times 24, because you can again just put that over 1, is going to be 1,200 over x, plus then 100 times 6 is then 600x squared, which, if you go and you look at what they wanted you to find, you find that that is exactly the expression of the cost. Okay, right, let's look at 11.3. So in 11.3 they say, calculate the width of the box, that is the value of x, if the cost is to be a minimum. So again, normally, I know we had one little tricky one there where we wanted to calculate the minimum and we didn't set the first derivative equal to 0, but normally, 99% of the time, when you want a minimum or when you want a maximum, you set the first derivative equal to 0. So we say they want to go and they want to minimize the cost, so we go back to this cost function we have over here. So that's the cost function that we've established, and we're going to go and say, first things first though, I can't find a derivative if I have an x in my denominator. So I first just have to quickly fix up the algebra and say the cost is then 1,200x to the power of minus 1 plus 600x squared. And now it's in the format where I can actually go and I can find the derivative. So I can say the first derivative of c So minus 1 times 1,200 is minus 1,200x to the power of minus 1, so it's minus 2, plus then 2 times 600 is 1,200, and then x. So that's going to be my first derivative. But then remember, to find a minimum or a maximum, I set that first derivative equal to 0. And I'm going to just fix this up again and say it's minus 1,200 over x squared plus 1,200x. Now to solve that, because it's an equation with a fraction, we have to multiply by the LCM of the denominator, which is x squared. And I end up with 0 equal to minus 1,200 plus 1,200, and x times x squared is x cubed, which then means 1,200, there we go, just get rid of that, sorry, is then equal to 1,200 x cubed. Now if I divide both sides by 1,200, end up with 1 is equal to x cubed, and then if I put a cube root over both sides, I'll see x equal to 1. So the question specifically asked, calculate the width of the box, that is the value of x, for the cost to be a minimum, and that's exactly what I've done. I've calculated that if x is equal to 1, and they specified that all of this is measured in meters. That is correct. Yeah, so everything is in meters, so that means if the box has a width of 1 meter, then your cost is going to be at a minimum. So that's the end of this particular question. And again, this is the second last question of this worksheet, which is from the Department of Basic Education National Senior Certificate Exam, November 2019. So this is from last year's public school exam, and it's question 8. So in question 8 they ask, after flying a short distance, an insect came to rest on a wall. Thereafter the insect started crawling on the wall. The path that the insect crawled can be described by the following formula, which is that ht, meaning the height, that it is probably above the ground, or above the floor, I should rather say, if this is a wall, where h is the height in centimeters, so that's my height in centimeters. I'm just going to write down centimeters there so I don't make the mistake of meters, because a lot of the time we measure height in meters and then we accidentally think it's in meters, and especially if it's a strange unit, in this case centimeters, I just write it down over there. Above the floor, and t is the time in minutes, so t there, again slightly a strange unit, t is the time in minutes, just so I remember it's not going to be meters per second, this one's actually going to be centimeters per minute, and it is indeed the height above the floor. Okay, now, the first question, 8.1, says, at what height above the floor did the insect start to crawl? Meaning, what was the initial height? So this is back again to calculus of motion or rates of change, where the moment you want to go and you want to find the initial height, we have to remember it's where t is equal to 0. Okay, so we're going to say h of 0, and we're going to just substitute 0 in there. And please remember, if I substitute 0 in there, I'm left with minus 6 over here. If I substitute 0 in there, that's 0, so I'm left with minus 6 over there. So minus 6 times minus 6 is then going to be 36 centimeters. That was the height above the floor when the insect initially landed on the wall to start crawling. Okay. Right, then 8.2, how many times did the insect reach the floor? Now again, be very careful, because it's so easy to go and say, I now want to go and find the derivative, set it equal to 0, when in fact the question doesn't want you to find the derivative, it doesn't want you to find the rate of change, because this one simply asks, how many times did the insect reach the floor? Now logically speaking, the floor is at 0 centimeters above the floor, because the floor is obviously equal, well, it's the same height as the floor, so it can't be above it. I hope that makes sense, sorry about that. So instead of going and finding the rate of change here, no, we are going to say the height is equal to 0. And I'm not multiplying this out, and there's a very good reason I'm not multiplying it out, because multiplying it out actually makes it more difficult to solve this. There we go. So I'm going to first go and I'm going to take that negative out of that bracket, because it's very difficult to factorize this trinomial if there's a negative. So I'm going to take the negative out. and you can divide the negative away, or you can just throw it away because it's not going to make much difference to the answer. I'm just going to go and say let's divide by -1 just to get rid of that. So then over here I've got t minus 6. This one I'm going to go and I'm 2t times t gives me that 2t squared, and then this one is going to be 2 times 1, because if I have minus 4 1 I get that minus 3t. So that means my answer is going to be t equal to 6, or t equal to -1/2, or t equal to 2. Now obviously we have to be very careful about the context of the answers in this particular problem, because I can't actually go and get an answer of -1/2. That one is not possible. Whereas these two are quite possible. So that one says 2 minutes, because remember we said this is in minutes. 2 minutes after the insect lands on the wall, it crawls all the way down to the floor. And then again, 6 minutes after it landed on the wall, it crawls all the way down to the floor. But it doesn't make sense to say at -1/2 minute that it's down at the floor. So this one we can throw away and we can just look at these two. Okay, so that's why they ask how many times did the insect reach the floor? It reached the floor twice. Oh, by the way, if you try to do the sum almost too easily, meaning you just looked at the expression and you said, oh, that's linear and this one's quadratic, so that's going to give me 1, 2, 3 answers, and you used an answer of 3, you would have gotten 0 for the sum, because you did have to first go and check if answers were valid. So that's why you can't just go straight to an answer. You had to go and you had to solve that equation. Okay. So next one, 8.3, then say, determine the maximum height that the insect reached above the floor. Now that specifically, again, that's my optimization. Optimization is going to be generally the first derivative equal to 0. So in this case, we haven't gotten the first derivative yet, and we haven't gotten the first derivative yet because we first need to go and we need to multiply this out. That ht is equal to t minus 6 times minus 2t squared plus 3t minus 6. Please remember, we cannot go and find the derivative of a product. We first have to calculate the product. So we first have to go and say multiply there, which is minus 2t cubed, multiply there, which is plus 3t squared, and then multiply over there, which is going to be minus 6t. Then multiply these two, which is plus 12t squared. Multiply that, which is then minus 18t. And I'm running out of space here, but the last little product over there is then going to be plus 36. I'm just going to clean it up and say it's minus 2t cubed. I'm going to add those two like terms, which is plus 15t squared. Going to add those two like terms, which is minus 24t plus 36. So now it's in a format where I can find the derivative. So my first derivative over there is then minus t squared plus 30t minus 24. And that I said equal to 0 to find my minimum. What's this? The maximum height. To find my maximum height. So I am just going to take the minus 6 out over there just to make the whole thing slightly easier. There we go. And then I'm going to factorize. Again, you can just divide by that negative 6 because we really don't need that constant value for the answer. I'm going to factorize this, and it's going to be t minus 4 and t minus 1. So that means we have t is equal to 4 minutes or t is equal to 1. Now again, if I have two answers, you can't just go and keep both answers, because one of the answers is probably going to be a minimum and one of the answers is probably going to be a maximum. Now that specifically, if you go back to the previous answer there, and this is what makes it slightly tricky sometimes if we have these type of expressions. We said that it reaches the floor at 6 and at 2, and the floor should be the minimum. But unfortunately, because this, when I multiplied it out, you saw it was a cubic expression. It does have a couple of places where the graph doesn't actually model the problem properly, because it is quite possible that this graph could dip below the x-axis, which in the context of the problem isn't really practical. I mean, unless the insect can actually crawl through the floor, it can't really reach a negative height. So we can't just go and say, okay, but why do we have two values here, but the minimum is 0? So what we're going to have to do is we're going to have to kind of stick to not practical stuff here. We're going to have to stick to what we already know about how to check whether something is a minimum or something is a maximum. Now, the one way we could do it is we could just look at this as though it is a graph, and we can say it's a cubic graph specifically because this is a negative value. It's a cubic graph that has this shape right there. So you could use the shape of the graph. Remember, we always start going from right to left. We first draw that negative shape, like the negative parabola, and then we continue. So that's how we know this is the shape. And this is quite useful because that means the very first value I'm going to encounter there is not going to give me a maximum. That's going to give me a minimum. Whereas the second value I'm going to encounter is going to give me a maximum. So you could just use the shape of the graph and you can say this is not going to give me my maximum. This one is going to give me my maximum. And therefore I can then substitute that back to get that maximum height. The other option was using my second derivative test. You can definitely have used that. You could have said second derivative going from here is then equal to minus 12t plus 30, beg your pardon, and then I can substitute t with 4, and if I substitute t with 4 over there, I can just go and say it's minus 12 times 4 plus 30, which is going to give me minus 18. And because the second derivative is negative, you guys should know by now, second derivatives are negative where it's concave down, which means it's going to be a maximum. So this is a maximum, so you know for a fact this one's going to be a minimum. So that was just one of the ways you could have checked which of those two answers is the correct answer. But I think we have established that t equal to 1 is not going to give me a maximum, t equal to 4 will give me a maximum. So what will be that maximum? That maximum we need to find by substituting 4 back, careful, into the original equation, because the original equation is what gives me the height above the floor. So that's why I need to go and substitute 4 back in here and say it's minus 2 times 4 cubed, 15 times 4 squared, minus 24 times 4 plus 36. And that's going to give me 52, careful, remember it's in centimeters. So the maximum height that this insect reaches above the floor is 52 centimeters. So that's the end of this particular question. Hello. This is then the last of the questions on this particular worksheet, and this one should go very, very quickly. It says in question 10 of the November 2012 DBE National Senior Certificate Examination, a particle moves along a straight line. The distance, s in meters, of the particle from a fixed point on the line at time t seconds, so this is meter per second, is given by this particular formula. So that just gives me the movement of the particle, specifically that is, we've spoken about represents displacement, but like I said, you can just go and you can say distance instead of displacement, especially if you are not a physical sciences student. Okay, now it asks you calculate the particle's initial velocity. So we've spoken about the whole idea of initial displacement and initial velocity. Careful though, people, because this does not give me velocity, this gives me displacement. So I first have to go and I have to find the velocity, which is equal to the derivative of displacement time. So looking at that, it's going to be 4t minus 18, which means the initial velocity is where t is equal to 0. So I substitute 0 in there, and then 4 times 0 is equal to 0, so it's minus 18 meters per second. And remember, we've spoken about that as well, that you could have a negative displacement, you can have a negative velocity, so please don't go and say something's wrong over there. This is very, very possible. Good. Next question. The next one then says, 10.2, the rate at which the velocity of the particle is changing at t seconds. Now, again, it's the words that makes this one difficult. It says determine the rate at which the velocity is changing. So we want the rate of the velocity, and now please, we just found the velocity in the previous question. We said the velocity is equal to 14 minus 18. So if I want to know the rate at which the velocity is changing, I need to find the first derivative of velocity, because that's going to be the rate of the velocity. Whereas this one that I worked out previously, the rate of the velocity, this is the rate of the displacement. Okay, so please just watch your words carefully. Okay, so this one, if I find the derivative there, I'm just going to go and I'm going to find 4, which, by the way, hopefully you guys should know by now, because we did discuss this, that if I find the rate of the velocity, or the first derivative of velocity, it's my acceleration. So this is going to be 4 meters per second squared. And that's why they just say determine the rate at which the velocity of the particle is changing at t seconds. At t seconds it's 4, because the acceleration, or the rate at which the velocity changing, is constant. It's always going to be 4 meters per second squared. Then 10.3 asks, after how many seconds will the particle be closest to the fixed point? So closest refers to, in other words, a minimum distance. So it refers to distance or a minimum displacement. So if I want to go and find the minimum displacement, I have to set the first of displacement, or the velocity, equal to 0. So it's going to be where the displacement, the rate of the displacement, is equal to 0. That's where I will have the minimum displacement. So I can just go back to this one, because remember the velocity was the rate of the displacement. So 4t minus 18, and equal to 0. So t is going to be equal to 18 divided by 4, which is equal to 4.5. And they said, after how many seconds will the particle be closest to the fixed point? And that's my answer. Unlike the previous example where we had to check which one is a minimum and which one is a maximum, if I get only one answer, then the answer is going to be what I'm looking for in this case, the minimum, because where will it be closest to the point. Okay, so that's the end of the memo.